Let us take up numerical methods, of which the first area is solution of nonlinear equations. Nonlinear equations can basically come in two types. They can be nonlinear algebraic equations or transcendental equations, which are basically non-algebraic equations. So the general idea is, if you are given an equation f of x is equal to 0, how do you find the root of this equation? If you denote the root as alpha, then alpha will be a root if it satisfies the equation. Of course, because the nature of these equations will be not that easy, therefore you may not have exact methods to solve them. Therefore, by adopting numerical methods, we can get approximations. Normally, when you want to solve a nonlinear equation, you think of some standard numerical methods. The most popular is the Newton-Raphson method. Then you have regular-Falsy. Then you have the method of bisection. Then you have what is known as a fixed point iteration. The syllabus is not very clear how many methods should be covered, but normally at the BTech level, the first three methods are normally taken up. Therefore, we'll have a quick review about how each method has to be applied before we take up a set of illustrations. So when it comes to the Newton-Raphson method, if x0 is an initial approximation to the root, then all successive approximations can be obtained from xk plus 1 is equal to xk minus fxk by f dash xk, where k takes values from 0 to infinity. For example, for k is equal to 0, you get x1 is equal to x0 minus fx0 by f dash x0. When it comes to false position, let us say the root lies between x0 and x1. Then you can estimate x2 by a formula. Couple of formulas are there, but one of the easiest ones is x0 mod fx1 plus x1 mod fx0 by mod fx0 plus mod fx1. You will then have to investigate whether the root lies between x0 x2 or x1 x2, and accordingly keep on extending this formula. And then when it comes to bisection, if the root lies between x0 and x1, then x2 is just the midpoint of these 2 points. Then you will have to see whether the root lies between x0 x2 or x1 x2, and accordingly bisect that interval and then proceed. Now we would like to also mention the rates at which these methods work. Therefore, there is something known as rate of convergence, which we normally denote as P. P is equal to 2 for Newton-Raphson method, P is equal to 1 for bisection, P is equal to 1 for regular-Falsy. There is another method called secant method, which is very close to false position, and that is having a convergence rate of about 1.6, and that is in between Newton-Raphson method and the regular-Falsy. So we are not discussing the secant method here, but these points can be remembered. The best rate of convergence Newton-Raphson method has, so we call it quadratic rate of convergence, whereas bisection and false position have got linear rate of convergence. So let us use these principles to solve a few problems which have appeared in the previous GATE exams. Let us look at some problems on solving nonlinear equations. One thing which has been observed is, in most of the exams, the Newton-Raphson method has been particularly targeted. So we will cover all those areas, and at the end we'll add 1 or 2 questions on the remaining 2 methods also. Question number 1. A numerical solution of the equation f of x is equal to x plus root x minus 3 is equal to 0 can be obtained using Newton-Raphson method. If the starting value is x is equal to 2 for the iteration, the value of x that is used in the next step is, the options are 0.306, 0.739, 1.694 and 2.306. So this is a given equation, it's a nonlinear equation and the starting value is prescribed in the problem. We have to find out the value of x in the next iteration by the Newton-Raphson method. So you know x1 is x0 minus fx0 by f dash x0. So let us first see what is f dash x. This is 1 plus 1 by 2 root x. So let's apply. x0 is 2 minus f of x0. So in this equation you put x is equal to 2. So 2 plus root 2 minus 3 by 1 plus 1 by 2 root 2. So this is 2 minus root 2 minus 1 into 2 root 2 by 2 root 2 plus 1. So all that you need is a calculator and the answer is around 1.6. You have to use a calculator, you know that's available to you, and this corresponds to option C. Question number 2. The recursion relation to solve x is equal to e power minus x using Newton-Raphson method is, the options are xn plus 1 is equal to e power minus xn, xn plus 1 is equal to xn minus e power minus xn, xn plus 1 is equal to 1 plus xn into e power minus xn whole divided by 1 plus e power minus xn, and the last option xn plus 1 is equal to xn squared minus e power minus xn into 1 minus xn minus 1 whole divided by xn minus e power minus xn. Now first let us write the general formula. Xn plus 1 is equal to xn minus fxn by f dash xn. So this is the general recursion formula for a function f of x to find its root. In this problem, f of x is equal to x minus e power minus x, because you have to bring all the terms on one side. F dash x is equal to 1 plus e power minus x. So you use that in this notation and you will have xn plus 1 is equal to xn minus of xn minus e power minus xn by 1 plus e power minus xn. So we just simplify this. Xn plus xn e power minus xn minus xn plus e power minus xn upon 1 plus e power minus xn. So these two get cancelled, and from the remaining terms you can take e power minus xn common and you will get xn plus 1 is equal to xn plus 1 e power minus xn by 1 plus e power minus xn. So this is a recursion formula to solve this equation, and you can see this option in C. Question number 3. The equation x cube minus x squared plus 4x minus 4 is equal to 0 is to be solved using Newton-Raphson method. If x is equal to 2 is taken as the initial approximation of the solution, then the next approximation using this method will be, the options are 2 by 3, 4 by 3, 1, 3 by 2. So again Newton-Raphson method. He is asking us to estimate x1. So the formula is x0 minus fx0 by f dash x0. F dash x for this problem will be 3x squared minus 2x plus 4. x naught is 2. If x naught is to substitute x is equal to 2 here, 8 minus 4 plus 8 minus 4 divided by f dash x naught, put x is equal to 2 here, 12 minus 4 plus 4. So on the numerator, minus 4 and 8 will get cancelled, and here these two will get cancelled. So 2 minus 8 by 12 is 2 by 3. This gives us 4 by 3, corresponding to option B. Question number 4. When the Newton-Raphson method is applied to solve the equation f of x is equal to x cube plus 2x minus 1 is equal to 0, the solution at the end of the first iteration with initial value x naught is equal to 1.2 is, the options are minus 0.82, 0.49, 0.705 and 1.69. So another simple question, x1 is equal to x naught minus fx naught by f dash x naught. So x naught is 1.2 minus of f of x naught is 1.2 cube plus 2 into 1.2 minus 1. The derivative of the given function is 3x squared plus 2. Therefore, it is 3 into 1.2 square plus 2. You use a calculator and you get an approximate answer 0.705, corresponding to option C. Question number 5. Solution of the variables x1 and x2 for the following equations is to be determined by employing the Newton-Raphson method. Equation 1, 10x2 sin x1 minus 0.8 is equal to 0. Second equation, 10x2 squared minus 10x2 cos x1 minus 0.6 is equal to 0. Assuming that the initial values are x1 is equal to 0 and x2 is equal to 1, the Jacobian matrix is. So there are 4 options. Let us see which one is true. Now this is a very special problem because we are using Newton-Raphson method for solving a system of equations. Okay. So now first let us look at a situation where you have two functions in two variables x1 and x2. The Jacobian matrix is given by dou f by dou x1, dou f by dou x2 in the first column, dou g by dou x1, dou g by dou x2 in the second column. Of course, you can also write the transpose of this. Now, let us find dou f by dou x1. This is the first function, this is the second function. So differentiate this partially with respect to x1 and you will get 10x2 cos x1, and then this element dou f by dou x2 will be 10 sin x1. When you go to the second equation, we are working on the second column now. So with respect to x1, this is 0. So you'll get 10x2 sin x1, and this with respect to x2 will be 20x2 minus 10 cos x1. So at x1 comma x2 is equal to 0 comma 1, which are the initial conditions which are given, j will be x1 is 0, therefore cos 0 is 1 and x2 is equal to 1. So this value becomes 10. This one becomes 0 because sin 0 is 0 and again sin 0 is 0, and then this will be 20 into 1 20 minus 10 into cos 0, that becomes 10. So this corresponds to option B. Question number 6. Let x square minus 117 is equal to 0. The iterative steps for the solution using Newton-Raphson method is given by. There are 4 options. Let us see which one will yield the correct one. There is a very famous result which we can quickly understand. Basically, if you look at this problem, it is to find the square root of a positive real number, right? So what we do is, look at this problem. So x squared is equal to n, or x square minus n is equal to 0. You call this the function. In fact, our problem is given to be like that. F dash x is equal to 2x. So xn plus 1 is equal to xn minus fxn by f dash xn. So this will be xn minus of xn square minus capital N by 2xn. So this will be 2xn square minus xn square plus n by 2xn. So this will be xn squared plus capital N by 2xn. So you can now write a rule. For all square root problems, xn plus 1 is equal to half of xn squared plus xn is xn plus capital N by xn, where n is the number whose square root we want. In this case, this is n. So the rule should be xn plus 1 is equal to half of xn plus 117 by xn. This corresponds to option A. Question number 7. The equation e power x minus 1 is equal to 0 is required to be solved using Newton-Raphson method with an initial guess x naught is equal to minus 1. Then after one step of Newton's method, the estimate of x1 will be. There are 4 options. Let us see which one is correct. x1 is equal to x naught minus fx naught by f dash x naught. F dash x for this problem is simply e power x minus 1 minus of f of x naught will be e power minus 1 by f dash x naught will be e power minus 1. So this will be minus 1 plus 1 by e power minus 1 minus 1. So this will be e minus 2. So this will be approximately 0.7, because this will be 2.72 minus 2 will be about 0.72. So option A for this problem is correct. Question number 8. The function f of x is equal to e power x minus 1 is to be solved using Newton-Raphson method. If the initial value of x naught is taken as 1, then the absolute error observed at the second iteration is. There are 4 options. Let us see which one is correct. We have to perform 2 iterations, x1 and x2. This is x naught minus fx naught by f dash x naught. This is x1 minus fx1 by f dash x1. So f dash x for this problem is simply e power x. So let us see what is x1. 1 minus e power 1 minus 1 by e power 1. So this becomes 1 minus 1 plus 1 by e. So 1 by e is about 0.3. This will be 0.3 minus e power 0.3 minus 1 by e power 0.3. So we'll get a certain output which you have to calculate. Now what he is asking, is the absolute error at the end of the second iteration. So it's just asking mod x2 minus x1. So whatever is the value you get here minus that should give you the answer. And it approximately settled down to 1.2, which is option C for this problem. Question number 9. If a continuous function f of x does not have a root in the interval a comma b, then which of the following statements is true? F of a into f of b is equal to 0, f of a into f of b less than 0, f of a into f of b greater than 0, f of a by f of b less than or equal to 0. A very fundamental question. Even before we think of applying a method, there is one area known as the location of a root in an interval. Now this graph should explain to us how the root is to be identified. Suppose alpha is the root, that is the point where the curve crosses the x-axis. We say that the root lies between the interval a comma b if the value of the function at x is equal to a and the value of the function at x is equal to b. So these are the values of the function at x is equal to a and x is equal to b. So this is positive, this is negative. So if the root lies between a and b, this condition should be satisfied. So option B would have been correct if he says the root lies in the interval. But you can clearly see he says f of x does not have a root in the interval a comma b. That means between a and b the function should not cross anywhere. So that is possible only f of a and f of b have the same signs. So you can clearly see that option C for this problem will be correct because he is saying root does not lie in that interval. Therefore, f of a and f of b must both have the same signs. Question number 10. The equation x cube minus 4x plus 1 is equal to 0 has a real root in the interval 0, 1. After one iteration of Regulov-Olsey, the approximate value of the root is, there are 4 options, let us see which one is correct. Regulov-Olsey or false position are one and the same. So, given x0 as 0 and x1 is equal to 1, we can estimate x2 using x0 mod f x1 plus x1 mod f x0 by mod f x0 plus mod f x1. That was already discussed in the review. So, if you now see what is fx0, you will have to put x0 in this and you will get 1. Fx1 will be 1 minus 4 plus 1, which is minus 2. So x2 should be 0 into fx1. It does not really matter. We have to take the modulus plus 1 into 1 by fx0 is 1 mod and mod fx1 is 2. So you will get something like 1 by 3. 1 by 3 is approximately 0.3. So let's once again see the correctness of the solution. Fx0 is 1 because you substitute x is equal to 0 and fx1 will be to substitute 1. So 1 minus 4 plus 1 is minus 2. We substitute in that rule. So this term gives nothing. x1 is 1, mod fx0 is 1, by mod fx0 is 1, mod fx1 is 2. So you get 1 by 3, which is 0.3. This corresponds to option C. Question number 11. The equation x cube minus x minus 1 is equal to 0 has a real root in the interval 1, 2. After one iteration of the bisection method, the root is approximately. There are 4 options. Let us see which one is correct. Anyway, just for the sake of testing, this is x0, this is x1, let us see what is f of x naught. It is 1 minus 1 minus 1, so it is minus 1. F of x1 is 8 minus 2 minus 1, which is 5. So you can see these are opposite in sign. So the root definitely lies between 1 and 2. So this is correct. So what we need is x2. x2 is equal to x naught plus x1 by 2. So this will be 1 plus 2 by 2, which is 1.5. This is where the root is located. So it's too simple a question to be attempted. So option A is correct.